Today we are solving systems of equations by elimination. This method uses the addition property of equality. Look at this system. Since the two sides of the first equation are equal and two sides of the second equation are equal, if I add the two equations together, both sides will still be equal. More importantly, 4x and negative 4x are opposites. When I add them together, I get 0, eliminating the x term, and I can solve for y. Once you have solved for y, you can now plug that value back into one of the original equations and solve for x. Our solution is 7, 4. To check your solution, you can plug both of those values back into the original equations. The solution will make both equations true. To work, the method depends upon adding terms that are opposites. Look at this example. There are no opposite terms. We can fix this by using the multiplication property of equality. If I multiply everything in the second equation by 2, I can create opposite terms. I choose 2 because 2 times 4x will equal 8x, and 8x is the opposite of negative 8x. I don't change anything in the first equation, but I multiply everything in the second equation by 2. Remember to multiply everything on both sides of the equation. Because we have opposites, the x term disappears when we add the equations. Now add the equations together and solve for y. Once I have the y value, I can plug it back into one of the original equations to solve for x. I choose the second equation because it looks easier. The solution is -3, -5. There is an error in the original example. Please use this example instead. In this example, I cannot see a way to multiply just one of the equations to get opposite terms. Instead, I will multiply both equations. I choose the coefficients of x variable because they're already opposites. I take the 4 from below and put it above, and the 3 from above and put it below. When I multiply 4 times 3, I'll get positive 12. When I multiply 3 times -4, I will get -12. Multiply everything in both equations and then add and solve for y. Plug in the value of y into one of the original equations. I choose the first, 3x plus 5y equals 10. Now you can solve for x. The solution is 5, -1. To check your answer, plug both values into the original equations. A correct solution will make both equations true. Let's see what special cases look like when solving by elimination. Look at this system. I notice that I can multiply the top equation by -3 to get opposite terms. I multiply everything in the top equation by -3. Now I add the equations together. I get 0 equals 0, a true statement. This means I have the same line. This is an infinite solutions, also known as a dependent system. In this case, I'm going to multiply everything in the top equation by 2. When I add these two equations together, I get 0 equals -6, a false statement. These equations represent parallel lines. This means I have no solutions. This is called an inconsistent system. In conclusion, systems that have one solution are called consistent and independent. Systems that have infinite solutions are called dependent, and systems with no solution are called inconsistent. Please use these notes as you do your homework. Thank you.